discuss about the stress in the bars of uniform tapering circular section. It is a simple derivation we will discuss now. So, this is the diagram. Now, consider the circular bar AB, A and B of uniform tapering circular section as shown in the figure. Right. Now, P, which means P which is equal to pulling force, pull on the bar, and L which is equal to length of the bar, L which is equal to length of the bar, and D1 which is equal to bigger diameter and D2 which is equal to smaller diameter. Right. At the end, two ends, it is a taper section. So, the left end which is a bigger end D1 and D2 which is a smaller end. Right. So, now consider the small element of length dx of the bar at a distance of x from the bigger end. Right. So, now let us consider this section, it is a small element. Right. The length of the small element which is called dx. Right. So, now we have to find the diameter of this section. Right. So, dx which is equal to d1 bigger diameter minus d1 minus d2 divided by L into x. So, this is the general formula if we want to calculate the intermediate diameters from this uniform taper section, right, or uniform taper bar. If you want to find out the intermediate diameter of the uniform taper bar, so this is the general formula dx which is equal to d1 minus d2 divided by L into x, right. So, this is actually total x, right. So, for sake of simplification, see, now I am going to change this equation into d1 minus k into x, right. So, whereas k which is equal to d1 minus d2 divided by L, right. So, this term is converted to k for sake of simplification, right. So, now we want to calculate the cross sectional area of this element, right. So, for that Ax which is equal to, we know that the area of circle pi by 4 into d power square d square, right. So, here pi by 4 into dx which is equal to this value, right. So, d1 minus kx the whole square, right. We know that the formula stress which is equal to load by area, right, load by area, right. So, load which is equal to P, already we know that from this diagram. So, P divided by Ax, right. So, substitute Ax value, this is the Ax value, substitute Ax value in this place, right. So, then the equation is converted like this, stress which is equal to load by area pi by 4 into d1 minus kx whole square. So, 4p divided by pi into d1 minus kx the whole square, right. This is the equation for stress. Similarly, what is strain? Strain, we know that strain which is equal to Young's modulus. So, Young's modulus E which is equal to stress by strain. So, now strain which is equal to stress divided by Young's modulus. So, what is the formula? Here this is stress and strain. So, totally 4p divided by pi into d1 minus kx the whole square divided by E. So, this equation is converted to 4p divided by E pi into d1 minus kx the whole square, right. So, this is the equation for strain, right. So, now this is strain for the smaller element, right. Now, the elongation, strain, what is the formula? Strain which is equal to change in length divided by original length. Now, we want to calculate del L. So, del L which is equal to original length into strain. So, now here del L which is equal to L into strain. What is the equation for strain? Strain which is equal to 4p divided by pi into E into d1 minus kx the whole square into what is the length of the smaller element, the length of smaller element which is equal to dx, right. So, into dx which is equal to what? Del, change in length, right, change in length of the small element dx. So, change in length of the small element dx equal to this value, right. So, this is the change in length of smaller element dx. So, we have to apply this equation to the total taper bar, right. So, for that we have to integrate this equation, right. So, total extension of the bar del L which is equal to, we have to integrate, right. So, integrate this equation is applicable to the total bar. So, the lower limit 0 and the upper limit which is equal to L, right. So, 4p divided by pi e into d1 minus kx the whole square into dx which is equal to L, right. So, what are the common parameters? 4p divided by pi e. So, take out. So, 4p divided by pi e integrate 0 to L, right. So, dx divided by d1 minus kx the whole square, right. So, which is equal to, again I am going to write the same equation, 4p divided by pi e integral of 0 to L limit, this is lower limit, this is upper limit, and dx divided by d1 minus kx the whole square, right. So, we have to integrate this. So, for this 4p divided by pi e integrate 0 to L, right. So, this denominator value d1 minus kx into whole square we converted into numerator. So, for that d1 minus kx the whole power minus 2 into dx, right. General formula is there, general formula integral d1 minus kx the whole power, this is the equation, right. So, this is general formula is there, integral a plus or minus bx the whole power n which is equal to answer a plus or minus bx divided by n plus 1 into plus or minus b, the here the whole power n plus 1. This is the answer for this integration, right. So, now we have a minus kx the whole power minus 2. Here the formula is a plus or minus bx the whole power n which is equal to a plus or minus bx into n plus 1 divided by n plus 1 into plus or minus b. Now, I am going to write the same equation, a minus, because we have minus bx the whole power minus n, right. So, minus n which is equal to what is a minus bx the whole power minus n plus 1 divided by, right, minus n plus 1 into minus of b. Now, what is a which is equal to here d1. So, d1 minus kx the whole power minus 2. What is the answer? A which is equal to d1 minus what is b? Kx, right, the whole power minus 2 plus 1 divided by minus 2 plus 1 into minus of b, which means minus of k, right. So, this is the answer for this integration, right. Now, 4p divided by pi e, right, this is d1 minus kx the whole power minus 2 plus 1 divided by minus 2 plus 1 which is minus 1, right, into minus k. Here what is value? Minus 1, right. So, we have to apply in limit 0 to L, right. So, now we are going to apply upper limit and lower limit, right. So 4p divided by pi e into what is the value? Now we have to convert this, right? So d1 minus kx the whole power 1 should become to bottom denominator. So 1 divided by, so what is this value? Total minus 1 into minus k, which is equal to k, right? Here d1 minus kx the whole power 1, minus 1 is converted into 1 when it comes from numerator to denominator, right, into k. This is 0 to L. Now 4p divided by pi e into, we take k out, so k, right. So now 1 divided by d1 minus kx, right, and 0 to L. So we have to apply upper limit, lower limit in this equation, right. So now 4p divided by pi e k into 1 divided by, first we have to apply upper limit for this x, right. So d1 minus kl, right, minus of lower limit now d1 minus k of 0, right. How to convert this? So now 4p divided by pi e k into 1 divided by d1 minus kl minus of 1 divided by d1, right. This is after applying the limits. Now we have to simplify this. Again I am going to write the same equation, del L, which is equal to 4p divided by pi e k into 1 divided by d1 minus kl minus of 1 divided by d1, right. So we have to simplify this, right. So now 4p divided by pi e k into, right, we have to substitute k value. We know that what is the value of k? K, which is equal to d1 minus d2 divided by L. So this is the k value what we assumed in the first slide, right. So we have to apply k value here, 1 divided by d1 minus d2 divided by L into L minus of 1 by d1, right. So now k LL cancel. Now 4p divided by pi e k into, right, here also we have to apply k, right, here also we have to apply k, clear. 1 divided by d1 minus of d1 minus d2 minus 1 by d1. We have to apply k value here also. So 4p divided by pi e into d1 minus d2 divided by L into 1 divided by d1 minus d1 plus d2 minus 1 by d1, right. So d1 cancel, right. Okay. Now this denominator L will move to numerator. So what is the value? 4pl divided by pi e into d1 minus d2 into 1 divided by d2 minus 1 divided by d1. Okay. Now what is the value? We have to take LCM here, right. So 4, which is equal to 4pl divided by pi e into d1 minus d2 into, right. So d1 d2, right. Now here d1 minus d2, right. So, d1 minus d2 cancel. Now, del L which is equal to 4 pi L divided by pi E into 1 divided by d1 d2. Now, what is the final equation? Del L which is equal to 4 pi L divided by pi E d1 d2. This is the change in length of the uniform taper bar, right? Uniform taper bar. This is bigger end, this is smaller end, right? So, this is d2 and this is d1. So, del L elongation of this taper bar which is equal to 4 pi L divided by pi E into d1 d2. If d1 is same, d1 which is equal to d2 which is equal to d, which means diameter of the bar is uniformly throughout the L, which means the same diameter for throughout L, right? Then what is the formula? Substitute d1 d2 which is equal to d. So, del L which is equal to 4 pi L divided by pi E into d squared, right? Which means pi L divided by pi by 4 d squared into E, which is equal to pi L by, this is pi by 4 d squared which is equal to area AE, right? So, del L which is equal to pi L by AE for uniform diameter throughout the length, right? So, for del L for taper section, del L which is equal to 4 pi L divided by pi E into d1 d2, right? So, this is the derivation. If you have any doubt, contact me, okay, through YouTube. Thank you.